Model is going to predict what type of mail we are getting. So email that you are getting, first of all, it will get passed through the model. Now model can't read the email. Now what we have to do there, we have to create NLP pipeline. Now what is NLP pipeline that we are going to cover in the session today? NLP pipeline. Through NLP pipeline, the text is going to get converted in the form, you can say in the vector form or in the numerical form, so that it could be understandable by the model. And model is going to understand like what type of mail it is, spam or not spam. Then we have sentiment analysis. Sentiment analysis is very simple. Uh, Basically, like I think yesterday also, not yesterday, in the previous session, we have discussed about a few things about sentiment analysis. Sentiment analysis is going to be nothing but, you can say also it is known as opinion mining. From the given text, let's suppose one trend is going on Twitter. So you can see like trend is what, like people put hashtag and they will be writing their tweet based on that. Now you want to understand what exactly the sentiment people is having behind this particular text. By reading the text you can understand, but we have to also gather the whole thing. Like if I'm going to collect all the data of that particular trend, and I can simply analyze how many tweets are positive about that trend, how many tweets are negative, how many tweets are neutral, right? So we can also identify the mood of the person. Like if a person is going to give review of the product anywhere, what the person is feeling about that particular product. So companies try to understand like what exactly customers want, right? How customers are feeling about the product. Are they happy about the product? Are they sad? Are they angry? So this type of things companies used to do. And all of you might have gone through this particular thing, spelling correction. Now, spelling correction, the use of NLP, it is not like it just came 5 years ago, 6 years ago. Those who have used MS Word in 2010, we are talking about MS Word. This thing was there itself in MS Word also. In MS Word, whenever you're going to write the wrong spelling, it used to underline. But if you talk about the software that you were using in 2010, it was not giving you the suggestion. Now it is giving the suggestion. Now the thing is that it was there. Not only here, at many places you are going to find out uh, spelling correction is there in your phone. Whenever you're going to write an email, over there also you will find all these things. And there is one very good software. How many of you have heard about Grammarly? Have you heard about Grammarly? Yes or no? Right? Grammarly is also one of the best example of NLP. So Grammarly basically is getting used. Let's suppose you will turn on Grammarly in your system, and wherever you are typing something, it will be having the focus on the text, and you can ask Grammarly to rephrase this. Let's suppose you have written the email. You have already written the email, but you don't know that email is professional or not. So you can ask Grammarly to rephrase it. Yes, right, Slok. Right answer. So Slok told like for rephrase and autocorrect. Yes, all these things are there. Even if we are writing an email, some spelling mistakes are there. So these things are getting considered, right? If you're writing any email in the office, you should be you should not make any grammatical error. But nowadays, what people are doing, people are using Copilot or ChatGPT directly to write the email. Fine. And the best thing that NLP gave us is the chatbot. Chatbot. Now, if I'm going to ask you like what exactly ChatGPT is also a type of chatbot, but more than a chatbot. And now, how it is started? It starts from NLP on. Now, if you have to understand how generative AI tools work, so generative AI tools mostly produce what? Nowadays we can see like we can produce or we can generate images and all, but when it came in the existent, it was only generating text, it was generating code, emails and all, right? So here NLP is going to be base of all the things. Now those who want to make their career in Gen AI, or let's suppose you want to become Gen AI engineer, guys, I'll tell you, you have to be very good in the basics that is coming from NLP, because in interview they are going to check your basics. Okay, so basics will come from here. We are working on the root level right now. So chatbot you will find everywhere nowadays. Go to the railway website. I think you might have seen in IRCTC app, or even if you're going to book flight from any companies, you will find there will be a chatbot. Chatbot basically they are working as a customer assistant, right? They are going to assist the customer. Fine. Simple question and answer. But ChatGPT, why I'm saying ChatGPT is more than that, or Copilot is more than that, because here it is generating new things. Chatbot basically it is not generating new content. It is just working on the facts. Frequently asked question. It will try to take your data. Data means what? Let's suppose your PNR number and all. It will try to help you on that. But this generative AI tool is different. GPT generates image also. Not GPT, not GPT, Pujan. If I'm going to talk about GPT, if you're talking about Chat GPT, then it's fine. If you're going to say GPT, I will consider GPT model. Now GPT-2, it's Chat GPT, right? So GPT model don't is not going to generate image. GPT 5.2 that we are having, or the previous model, now they can generate image, right? Fine. So these are the applications, and a few are the terminologies over here that I will be using. Okay, I got one thing from Sujal. Chatbot is that area specific, and ChatGPT is covering everything. Yes, exactly. Look, when we create chatbot is going to be domain specific, as Sujal told. True. But ChatGPT is meant to generate new content. It is working on GPT concept, generative pre-trained transformers. And guys, as I told you, like if you want to master this particular thing, like, or let's say you want to create your own GPT from the scratch, GPT model, not high scale, but low scale you can create. For that, you need all this, knowledge of NLP. Fine. Okay, I will be talking about terminologies over here. But before going ahead, let's try to understand how basically NLP works. I will take you to the drawing pad. And guys, I will be asking a lot of questions over here, so be ready. So we are going to start with NLP, that stands for Natural Language Processing. Okay, so basically NLP is going to be a way in which we try to convert the text in a form that model can understand. The data we have to convert in the way that is understandable by the model. Now, what we have done previously, whatever we have done previously, I am going to tell you. So previously, we used to have the data, right? We used to have the data. Data, we used to give it to the model, right? Data, we used to give it to the model, and model used to give us the output. Right, this is what we have done so far, right? If I'm not wrong. output. We took the data, we give it the model, model got trained, and model is giving the output after training. But here, what is going to happen? We are going to have data, but this data is going to be in the form of text. This data is going to be in the form of text. Now, we know, like you will tell, okay, sir, after data, we did data pre-processing. So similar way here, we are going to include one thing that is going to be text pre-processing. Text pre-processing. And guys, this part you can say where we are going to use all the NLP techniques, where we'll be building the pipelines. And after this, it is going to be the ML part. ML, like classification, regression, all the things you have already gone through. That thing will come again. All right. So here, what we are going to keep, nothing but the model. And then model, what model is going to give us the output. Model is going to give us the output. Okay, now what are the things involved over here in text pre-processing? So we'll be talking about this thing over here in a very, efficient manner. Whenever you are going to get the text, you are going to perform tokenization. I will put it into the form of labels, like what are the labels you are going to complete. Tokenization. Tokenization. Now, tokenizations can be in different form. It could be sentence tokenization, or it could be word tokenization. Now, what does tokenization means? Tokenization means nothing but breaking down the text into tokens. Now, tokens is nothing but the chunks of the text. We're talking about the chunks. If I'm having a paragraph, if I'm converting the paragraph into lines, that means I am performing sentence tokenization. If I'm having the paragraph, if I'm breaking it out into words or the list of words, that means I'm doing word tokenization. Now each word is going to be considered as tokens. Then if I'm performing sentence tokenization, that means each sentence will be considered as one token. But most of the time, we prefer word tokenization because most of the time we'll be working on each word. Once you are getting the words, what you are going to do, you are going to perform over here, that is called stemming or lemmatization. Stemming or lemmatization. And there is one more thing, we call it as stop words removal. Stop words removal. Stop words, what are the stop words? Now let's say you are making an model that is going to, or you're training a model that is going to predict the email is spam or not spam. Now give me an answer. Now do you think uh, if I'm going to use the word, if I'm going to train the model on the word like I, me, should, could, all these helping verbs and what we can say pronouns, are these words are going to help me to train the model or give the model the context, the mail, the email that we have got is spam or not spam? No, right? Darshan is saying no. What about others? No, right? Prasant, Release, Aswin, Jay. All right, Pujan. Everyone is saying no. So what we need to do, we need to remove all those words. We need to remove all those words. Okay. So how basically we'll be removing those words? There are different ways. There are different ways to remove those words. So we will be using stop words module from the library NLTK. I will talk about NLTK, the toolkit. So we will be getting the list and taking the words from that list. We'll try to filter out the stop words from our corpus, our whole text, right? So here, why this thing is required, I'm not going to give the model the extra thing to learn, only the things that is required. Now here, I will optimize the training time of the model. I will also optimize the computation cost. So two things we are going to solve over here. Now, once it is done, let's suppose you have done all the things, you have removed the stop words and all, you have performed stemming lemmatization. I will be talking about each and everything one by one when I'm going to put it through the labels. Then we will be having vectorization methods. Vectorization. What is vectorization? Nothing but converting the text to vectors. Vectors, I hope you are aware about these terms, vectors. Vectors, you might have heard about vector first time in physics, maybe. Physics or math, but according to me, I have heard about vectors in physics. Yes, yes, in physics. Now, what exactly vectors are? Vectors are nothing but the numbers. Let's say, like this, you are having one particular list and you are having some numbers over here. These are going to be the vectors. Yes, embedding the words tokens to vectors. Yes, exactly. Okay, so these are the things we do in text preprocessing. Now, here I will be dividing the things into labels, guys, labels. And I will be talking about few things that we are going to discuss today. So I'm going to talk about level 1. In level 1, what we try to do, we try to perform text preprocessing. Text preprocessing. Now, what we do in text preprocessing in level 1, first of all, we are going to perform tokenization. Tokenization, right? We will break down the text into tokens, into chunks. So what basically tokenization is? Breaking down large text into chunks. Chunks, these chunks we are going to call it as tokens. Tokens, right? The next thing that we are going to perform is going to be nothing but let me just underline this thing. It's going to be stemming or lemmatization. Now, what we do in stemming and lemmatization, let's try to understand. I'm just going to take the example over somewhere here. Okay. Let's say I am having 3 words: cooks, cooked, cooking. 3 words we have. Can you tell me what is the root word of all these 3 words? Cook, right? Exactly, cook. Yes, everyone is giving me the correct answer, cook. Now, what we are trying to do, we are normalizing the text to its root form. This is the root form. This is nothing but the root form. This is what we try to do. We try to normalize the text to the root form. For that, we have 2 different techniques: stemming and lemmatization. Right? Yes, one example given by Viral. That is running ka run. Yes. If you are having running, let's say if I'm having running, it will be taken as run. Exactly. Fine, fine. Now here we are going to do the stop word removal. Stop words removal. We will try to remove the stop words. So this is going to be the first thing in your pipeline. Oh, now people will say, what is pipeline? Guys, pipeline is nothing but you are going to build uh, a workflow basically. Now we'll be talking about level 2. Level 2. Which are the stop words? Okay, which are the stop words? I will mention the stop words over here. Yes, the unnecessary words, right, Viral? Let me just mention stop words. Few people are saying, just a second, why eraser is not working? Just a second, guys. I'll write it down over here. Let's say I, me, should, could. These types of, words over here. This type of words. I can't put all those words because we have around 200 stop words in English language only. I'm talking about English language only. In English language, we have around more than 200, around 200 stop words. So pronouns and helping verbs like should, could, may, might, right? All these things. Is, yes, exactly, at, are, you will be having in between. So those things we'll try to remove. Sir, explain stemming again. Okay, Tejas. So stemming is nothing but stemming and lemmatization, both we are using to achieve the same thing. That is bringing the words to its root form. So here I have given the example. The first word is cooks, second one is cooked, third word is cooking. All these words are coming from this root word cook. So we try to normalize the words to its root form like this. Our goal is going to be to normalize the words to its root form. Right? Now we will be having level 2 over here. And guys, level 2 again is going to be about text pre-processing. Now you told me that, okay, you will tell me that, sir, already we have done text processing. Then now again, why now again? So here, what we try to do, we try to perform vectorization. Once you have tokenized the text, once you have performed the normalization of the words, and once you have removed the stop words, that means you are having clean text. You got that clean text. Now the clean text need to get vectorized. So vectorization is going to be our next step. That means converting the text to vectors. Text to vectors. Okay, I will be talking about a few vectorization methods. So one of the vectorization method that we have, that we will be discussing, is going to be bag of words model, not machine learning model, bag of words model. And I will be talking about, let me just write it down over here, TF-IDF vectorizer, TF-IDF. Okay, one more thing is there Virala is giving, that is word to vec. Word to vec, and there are few more I will be discussing today. about this too when we'll be working on the project. Then once we are done with level 1 and level 2, that is the most important step. So here what exactly you will be having, you will achieve one the data set in the numerical format. Numerical format is what you will be getting in the vectors. Then we'll go to level 3. What is level 3 of NLP? We are talking about the levels of NLP, guys. Level 3 of NLP is nothing but, here very simple, not making it complex. We will be talking about ML use case. ML use case. And today we are going to work on a project that is going to be, the project name is going to be fake news detection or classification, whatever you want to call it, you can call it. Right? ML use case. Okay, then what will be the level 4 then? So level 4, we won't be discussing today because for level 4, you need the knowledge of deep learning over here. So we will be talking about in level 4 ANN use case. ANN use case means what? Applying the artificial neural network. Once you are done with all these things, I'm giving you a simple roadmap, guys. Okay. So we will be completing till level 3, not level 4 today, because level 4 needs the understanding of deep learning. So deep learning is also going to be discussed for you. We'll, after completing the level 4, we talk about level 5. Now, what is level 5, guys? Level 5 is nothing but, can anyone give me a guess about level 5? What should be the level 5? Anyone? Any idea? Any guesses? Deep learning, Sahil, deep learning is here. ANN is nothing but deep learning. Okay. So let me write deep learning over here. Deep learning. We have both approach, machine learning and deep learning, both approach. CNN, okay. If I'm going to talk about NN, CNN also you can keep it over here. Let's go beyond deep learning. What should be the level 5? Gen AI? Yes. Now to achieve Gen AI, what we should know, guys? Poojan is saying Gen AI. Okay, Gen AI is fine, but to achieve Gen AI, what is going to be the base of all the Gen AI? That's a neural network is already here. I'm talking about something between Gen AI and deep learning. Something coming in between. LLM. So what is the base of LLM? What is the base of LLM? Not agentic AI, not ML model. ML model we are discussing over here. Let me write down over here. So level 5 is going to be nothing about transformers. Now, transformers are the base of all Gen AI tool that you're having today. What is the full form of GPT? Right, generative pre-trained transformers. Right, so transformers are nothing but pre-trained models, made for some specific task. Right, made for some specific task. So these are going to be the level 5, and after completing this level 5, you will go to level 6, that is going to be talking about the LLMs and all, once you are going to learn all these things. Right? Clear till here, guys? Give me a thumbs up. Give me a thumbs up if it is clear till here. Quick recap of First of all, change your name, then I'll give you the quick recap. Is your real name? No? Okay, no problem. I'll give. Guys, no, this is for everyone. Don't take it like I'm pointing anyone over here. Whenever you're joining any meeting, okay? Whenever you're joining any meeting, try to join with a proper name, okay? Proper name, not with a nickname like Iron Man and all. This not looks professional, okay? And now let's suppose you are joining an interview call and you're joining with that particular names, right? Iron Man, Spider Man, Thor. No, this shows that you're not professional. Okay. Okay. Can you repeat about each levels? Yes, sure. I will be repeating about each levels. Sure. So I'm giving you a quick recap from here. So when it comes to NLP, natural language processing, here we try to create pipelines for the text. We will be working on textual data. So the main role of NLP is going to be nothing but performing the text preprocessing. Text preprocessing involves tokenization, stemming or lemmatization, any one technique, removing the stop words, and vectorization, converting the text to vectors. Level wise, if I'm going to break down, so level wise in level 1, we have text preprocessing where we try to tokenize. We perform tokenization. Tokenization is nothing but breaking down large text into chunks, or chunks we call it as tokens, right? Chunks. Let's suppose you have a large paragraph, you are breaking down the paragraph into sentences. That means your tokens are going to be sentences. Now, if you are going to break down the whole paragraph into words, list of words, that means you are having the tokens as words. Each word is going to be one token. Okay. The second thing is stemming or lemmatization. So stemming, lemmatization, both are getting used for one purpose. They have their different, way of doing the things. We'll be discussing, but the main concept behind stemming or lemmatization is going to be nothing but normalizing the text to its root form. Let me write it down over here. Normalizing the words. Sorry, not text. We will be talking about the words to its root form. Okay, sorry about the writing, guys. I know it looks like doctor's handwriting, but what can I do? I hope you can manage. And after performing stemming lemmatization, and these two are going to be interconnected, guys. How it will get interconnected, we'll see in the pipeline. We also remove the stop words. Stop words means what? This unnecessary text. If I am training a model to predict the mail is spam or not, or to predict the news is fake or not, so this type of words are not going to help me. So we are going to remove these things from the given corpus, the given text, the data, the text data, so that model will only get the important thing, not this useless things, right? Useless tokens. Only important tokens will be passing to the models. Once we are done with cleaning the text, basically here we are performing the text cleaning, right? Text preparation, you can say. Once the text is clean, we'll move to level 2. Level 2 is all about vectorization. Different vectorization techniques are there. Vectorization is nothing but converting the text to vectors. Vectors, nothing but numbers. We are going to talk about numbers. Numbers. Now, to convert text into vectors, we have a number of techniques. We have bag of words model, TF-IDF vectorizer, word2vec, and few more. Once you are going to convert the text to vectors, that means the text you have converted to the numbers. Now you will be ready to give that text to the model, that numbers basically. So text data, basically here what we are doing, we are having the data set where we are having only text data, right? Text data. Let's say you are having the label also. Now you are going to convert the text into a data set where you will be having only vectors or numbers, numerical data. All right. Once we are going to done with it, so we can simply go and implement with a machine learning model. Model choice depends on you, but what we prefer. Can it even tell me which algorithms we prefer when it comes to this thing, what we say, text classification? What type of models we prefer? Logistic, okay. Deep learning, no. Yes, classification. We are going to do classification. LSTM and all parts it will come when you're going to implement deep learning, right? Neural networks and all, RNN. Have you heard about SVM? Have you heard about NAP-based, right? So I'm not saying you can't use logistic regression. You can use logistic regression. If you want to use random forest, you can use random forest. But few of the models that are getting used, sorry, not here. Let me write it over here. Few of the algorithms that are getting used is NAP-based. NAP-based basically works on Bayes theorem. How many of you remember Bayes theorem? Then SVM, support vector machine, and few more. I'm not saying we are limited to only these two. There are few more. But model, uh, Manish, yes, Manish, but will come over here in transformers. Okay. Thanks for reminding me. So one of the transformer model that you can learn over here is going to be BERT, GPT, right? GPT-2 basically we'll try to see when we'll be exploring about transformers. Fine. I hope it is clear now. So wherever we can implement machine learning, we can also implement deep learning. For deep learning, we will be having ANN use case, that is ANN, CNN, anything. Here we also talk about RNN, and one more thing will be with RNN over here. That is going to be LSTM. Okay, so all these things we will be discussing when we will be completing deep learning. Okay, fine. I hope it is clear what exactly we are going to do. I will be showing you each and every step, what exactly is going to be done in step 1, step 2, and so on. Just a second, guys. Yes. Can you remind me one thing? In the last session, when you have got the lunch break, at what time was it? 1 o'clock or 2 o'clock? Okay, 12 to 1 you have got the lunch break, and after that 1 to 3 we had session. Okay, right, all right, got it. Thanks, everyone. Nisa, Nirmal, Louise. Fine. Thanks for reminding me. I was thinking 10 to 1 I will be taking, but fine. All right, let's go ahead now. I hope everything is clear till here. Can I get some thumbs up from everyone? And let me know if you are able to understand my handwriting. Yes, thanks for the quick response. Perfect, perfect. Now there are few terminologies, guys, that we need to understand. Okay, terminologies. What are the terminologies that is getting used in the field of uh, NLP? So terminologies goes like this: corpus. Now, and corpus we have, we will be having something called, let's say, document, then we will be having vocabulary, or we call it vocab, and then we'll be having words. Okay, first of all, corpus. I'm going to take a simple example over here. Corpus, if I am having, let's say, one document over here, one document I have, and I have some lines of text over here. Okay, some lines of text. Now this entire document that we have is going to be considered as corpus. The entire text, the whole text, we are calling it as corpus. Corpus means what? The entire text data. Now the part of this text data, let me just change the color over here. Part of this text data that you are having, let's say if you are having a paragraph, then each line is going to be your document. Corpus is the entire text data, and parts of that particular corpus are going to be considered as documents. Then we have vocab. Vocab is going to be nothing but collection. Let me change the color for better view. Collection of unique words. Unique words in the corpus. Whatever the unique words you have in the corpus. It's just like a no, dictionary, not Python dictionary. If I'm going to talk about dictionary, if you're going to see in dictionary, you won't find the word repeated. Yeah, some words are repeated, but here in our case, words are not going to be repeated. It is going to be, vocab is going to be nothing but unique collection of all the words, unique collection, like only the unique things will get included from the entire corpus. And by default, vocab is going to be stored. Vocab is going to store all the words in alphabetical order, like A to Z, A to Z. Then what are words now? What are words? Now, guys, words, it totally depends on the context. Okay. Now you will say simple English words. Yes, words only. But let's try to understand. So words, basically we can divide into three parts. Unigram, bigram, and trigram. What is unigram? What is bigram? What is trigram? Let's say you are having the word Delhi. Now what will happen when you are going to create, like you are going to convert the text into vectors? For each particular text, one column will get created. For Delhi, one column will get created. Okay. Now let's say you are having New Delhi. Now New Delhi, we know New Delhi are two different words, but this thing represents a single entity. Now, only one single column will get created for these two words, because these two represents a single entity, a city, right? Let me just erase the things from here. A single column. Now, trigram, I hope you can discuss. Can you give me one example of trigram? I hope you have guessed. Give me one example of trigram. Anyone? 3 words at a time. Fine. I need one example, Slok. Yeah, you have written the right thing. 3 words at a time. But can you give any example? Specific area. I need example. Like for unigram, I have given you one example, Delhi. Bigram, New Delhi. Day after tomorrow, no. Day after tomorrow, different thing. One right example, Jammu and Kashmir. Very good. Very good. Now I can't take your name. Your name is HP. But one very good example I have got. Jammu and Kashmir. Jammu and Kashmir, we know Jammu is different word and is different word. Kashmir is different word. But all this represents a single entity. No, as soon as no. The India Gate also not the India Gate. Yes, MK Gandhi Road, right? The White House, perfect. One more example I'm giving you, New York City. SG Highway, all right. APJ Abdul Kalam. Okay, now I'm getting good examples. Fine. I hope you understood the different terminologies. That is corpus, document, vocab, and words. Right? Let's come back. Madhya Pradesh is the example of Aryan. Madhya Pradesh is example of bigram, not trigram. Four-wheel drive. No, Manas. It is not. Repeat document again. Okay. Look, corpus is nothing but the entire text, the whole text that you're having in file, the file that you're having. And here what you're having, let's say document is going to be nothing but the part of that particular, or you can say simply the what we can say the single unit of that particular corpus. Madhya and Pradesh, no, it is not like that. Anuj. Andaman and Nicobar, very good example ones for trigram. Alright, so corpus is nothing but the entire text. Documents are going to be the part of the corpus. So each unit of a particular, let's suppose if I'm having a paragraph, each line in that paragraph is going to be considered a document. If I'm having a whole paragraph, I can convert it into let's say, if I'm having a page, let's say if I'm having a page, the whole page, and each paragraph in between the page is going to be considered as document. I hope you are getting it. Fine. Making sense now, everyone. I hope we are going in good pace. Okay, let's go ahead. Let's go ahead. Now, here we will be talking about the NLP pipeline. But before going into NLP pipeline, what we use some toolkit. Okay, we have some toolkits for NLP. We have some toolkits. Let me open the chat box. Just a second. Chat box got closed. What are the toolkits? we have toolkits. So the toolkit that we are going to discuss is going to be NLTK. NLTK. NLTK stands for Natural Language Toolkit. Now, one more toolkit we have. Yes, right, Manish Spacey. Okay, Spacey. We'll try to explore both if possible, if time permits. We'll try to explore both NLTK and Spacey both. As compared to NLTK, Spacey is going to be more efficient, but we need to understand. Div and Daman for trigram, right, Pujan? Daman and Div. Bombay Stock Exchange, right? Very good example. Manas. Bombay Stock Exchange. All right, guys. Now let's come back over here to the file. Over here. I'm going to share this file with you. And I'm also going to, the Lal Street is the example of bigram. Guys, I am sharing this particular file with you and I'm giving you only the viewer access. Okay. You will get only the viewer access. Collab link I have shared, and in the same file, I will be using one document, one data set. I'll tell you what exactly that data set will be about. But before using the data set, we'll be discussing about a lot of things, like the text processing steps, creating the pipeline. Yes, so the data set, I just need to check, yes, I'm taking it from, okay, let me do one thing. Let me check if I am having it in my drive. I will upload it. Just a second. If I'm not having it in my drive, then I'll upload it. No, I need to upload the dataset. I'm going to upload the dataset and I will be giving you the access to that file. Just a second. Okay. So this data set is going to be little large, not that much large, but bit large. You will be having around 20,000 plus records you will be having, but we are not going to use 20,000 records because when you are going to create the pipeline, that pipeline will take a lot of time to get executed, especially when you are going to remove the stop words, because you are going to use a for loop and that loop will go through each and every word and each and every line, each and every row, right? So these are the things. Fine. Once it is getting uploaded, I'll share the link. And guys, just download the file, keep it with you. If you want to run it locally, you can run it locally. Or else, if you want to use this particular file in your collab only, so I have one option. What option I have? You can select this particular option, save a copy in drive. Okay. Did not got collab link. Okay, I have. Okay, sorry, I just shared it to the host and panel. Okay, guys, here you got. I hope you are receiving it. I'm just going to share the file as well. Yes, this file also I'm going to share with you all. And based on this, you can create other project also, like spam email detection project or anything else. Okay. I'll let you know about one particular platform where you can go and you can use all this stuff. Yes, drive link also I have said. Drive link to this particular file, guys. I'm sharing again. Let me give the reference over here. What exactly you have? So this is the data set. Data set and collab link. I'm sharing it again. Notebook. I hope you have got both link. I have specified to reduce the confusion. One thing I'm repeating again, guys, what you can do, simply you can click on file and you will get this option, save a copy in drive. Okay. Let me open the chat. Yes. Have you downloaded the files, everyone? Dataset you can also download later on, but better to keep it. Here we'll be starting with few of the things here now. Okay. Perfect. First of all, I need to connect it to the server. Done. Okay, one thing here it is required. First of all, you need to install NLTK over here. NLTK. You will find it in the form of comment. Okay, the first cell that you're having. How to build NLP pipeline? First of all, we are going to do sentence segmentation. We'll see one by one all the things. Then we'll try to combine it. Okay. Okay. One student is asking. Okay, Chirag, do you want this file? I'll share at the end of the session then. Okay, fine. So let's get ahead. The line that I have given you over here, let me explain this line of code. Pip installed NLTK. First of all, you need to install NLTK. Two more lines I have added over here. It's represent upgrade and quit. Upgrade means what? If it is already installed, it will get upgraded. And you are not going to see the the installation part over here. If you don't want to see the installation part, you can put this thing hyphen quit. So for me it is already installed, so I'm not going to run this line of code, but you can run this line of code. Let me run this for you. Syntax error. What syntax error I have? All right, let me see if I'm able to import NLTK or not. If I'm able to import, that means it is already installed for me. Done. It is there. For me it is there. Yes, Pip. The thing is that last time I have used this file in Jupyter, so Jupyter Notebook. Yes, we need to put one exclamation mark. Right, Darshan. But for me here, you can see I'm able to import it. That means for me, it is already installed. You need to check from your own end. Now from NLTK, we'll be downloading few modules. So here we are having one module called Punct tab or Punct, right? So basically this Punct tab that we are downloading over here, it is nothing but one of the resource. It is one of the resource that contains pre-trained tokenizers, pre-trained tokenizer model that will help us to perform tokenization, like sentence tokenization and let's say word tokenization, all these things. I'm just clearing all the outputs as of now. So here I'm going to have one corpus. Okay, I'm going to have one corpus. Randomly, I have created one paragraph. So this paragraph is having nothing but a hello. Am I audible now, everyone? Sorry. There was a network problem from my end. Sorry about that. I'm sharing my screen again. Yes. So I think we were here only. I didn't move forward. Sorry, everyone. Again, I got disconnected. Am I audible now? Just give me a second. I have to change change one setting over here. Just a second. I have to switch to some another network. Yes. Fine. Um, we can continue now. All right. So here, what we are having the corpus. In this corpus, I have given only 4 lines. I don't drink coffee. What a wonderful day. Timon and Simba went for a party. India will play with Pakistan in World Cup. Okay. So 4 lines, random lines I have taken, and this is nothing but our corpus. For an example over here. Uh, in the meantime, our corpus is going to be the whole document. Okay, the text document or the text column in a particular file. Now here, what we have from NLTK dot tokenize is the model over here. Uh, the module from here we have send tokenize. So send tokenize is used to, just a second, one good question from Poojan I have got. Sir, if you have document, then in corpus we have to put the whole document in it. Okay, quite confusing, but now here people get also confused. Okay, document. Now the document I'm referring to the CSV file or Excel file. If I'm going to take the corpus, in that corpus, if I'm going to have one row, let's suppose I'm having a CSV file. Uh, that CSV file is having 1000 rows. That means 1000 document I will be having. Whole CSV file, the column, the text column is going to be the corpus. I hope it is making sense now, Pujan. Fine. Moving ahead. So here we have send tokenize. So send tokenize is going to be the module, the pre-trained tokenizer that will convert your corpus into sentences, list of sentences. Here we go. Now, as of now, these are the tokens. Okay, these are the tokens. Yes, exactly. That those 1000 rows will be the corpus, Pujan. Okay, then we have word tokenize. Now, the thing is that you have word tokenize module over here, but we usually don't use word tokenize, from here. Why it is so? You will see why exactly we are not using word tokenize modules over here. So word tokenize is there. We are converting the corpus into the tokens of words. Now here you can see. The first line was, I don't drink coffee. It is taken as I do NT drink coffee. Now here some mistakes are going on. So this is what word tokenize is going to make some mistake. What exactly we use? We use one string method called split. Now split is going to split the text into list of words. Okay, list of words. If you're not going to put the separator over there, then it is going to separate on the basis of spaces. So here we are going to see the split, and here you can see we are getting the proper words over here, right? Dot split. Similarly, we have few more tokenizers, but again, those tokenizers are of no use. Similarly, it will do this type of errors. Right. So these are the things that we need to focus, and majorly we'll be working with this corpus dot split. I'm not saying you can't work with this or this. You can work, but you can see what problem you are having. So split is going to be the best tokenization method we can see that directly come from strings. Now we are going to talk about the stop words. Okay. What exactly the stop words are? Many people were asking, sir, what is stop words? What is stop words and all? So let's see what exactly stopwords is. So nltk.download stopwords. So from corpus, nltk.corpus, we are going to import stopwords. Now, before using the stopwords from the toolkit, you need to download stopwords. Once you're downloaded, you don't need to download it again. You can use it. Now from corpus, we are going to import the stopwords, and stopwords, the module itself will be having some methods, and those methods will have different languages stopwords. Now here you won't be getting Hindi, Gujarati and all, but a few foreign languages are there. I'll show you. So as of now, what you can see, you have the list over here. You can see what you have, list of English stop words, right? And you can see what are the stop words. He will, he did, her, herself, he is, himself, I will, it will, am, might not. And here you can see like one more thing, might n. Why it has taken might n? Because sometime you can see this type of things will come. That's why this extra thing has been added. My, myself, no, nor, not. So everything we got in alphabetical order. These are the stop words, guys. These are the words that are sometimes it is not useful, so we try to remove it. So how we check basically word is there in the stop word or not? Let's say very. I want to check out very is there in the stop word or not. It's true. That means very is the part of a member of the stop words. How many stop words are there in English language? We have total 198. So I told you around what 200 stop words we have. So we have 198 stop words. All right, fine. So here, what exactly we are having over here? We are having the English stop words. We can check for other language also. What language? Can you give me any other foreign language? Anyone? Any other foreign language? French. Okay, let me use French. So these are the French stop words. You can see French stop words. Let me go for German. Okay, I'm getting German. German. Here you go. I'm getting German stop words. What is that? Spanish. Okay, Prasant is saying Spanish. Sahil told German. Poojan is also saying Spanish. Let me type Spanish. We have Spanish. Shubham is asking for Chinese. Okay, let me see. I'm not sure Chinese is there or not. If it is not there, we'll get error. Chinese is there. Chinese top words we have. Hindi. Hindi is not there, guys. I tried with Hindi. Let me check. Hindi is there or not. Hindi is not there. Okay. Hindi is not there. Sanskrit. If Hindi is not there, how you will be able to get Sanskrit? Sanskrit is also not there. Indian languages are not there. Jamaican. Jamaican is a language. Okay. Jamaican, it's not there. Marathi is also not there. Italian. Let me try with Italian. Italian is there. Hebrew. Okay. Russian. Okay. Russian we have. Arabic. Arabic we have. Japanese. Okay, this is the last thing. Okay, Japanese is not there. Did I mention the right spelling? Gujarati is not there, guys. Okay, let me type Gujarati. No, it's not there. French and German I already shown. Right? Guys, German I have already shown. German. Mandarin once, Mandarin, Chinese, I think it's same. But if you ask me to check for Mandarin, Chinese we have already taken. Mandarin. I'm not sure about the spelling. It's not there, but Chinese is there. Korean. Korean is also not there. Spanish we have. Okay. Uh, that's all, guys. That's all. That's all. Spanish is there. But we will be using English only. Okay. We have to focus on English. It's sad to see we have the best engineers in working in Silicon Valley, but Hindi is not there. Yes, I agree with you, Anuj. So you become that engineer, right? Fine. Now the next part is going to be we will be having stemming over here. So stemming is there, but stemming. Let me just fix few things. Yes. Stemming we basically use to normalize the word to its base form, or we can also say the root form. Like the word we have, I have given you one example: cooks, cooked, cooking. They belong to the root form cook. Similarly, we have celebrates, celebrated, celebrating. All these are originated from a single root word celebrate. This is what we try to do. We try to break down or bring back or normalize the words to its base form or root form. But there is a big problem in stemming, that sometimes it produces a root word which may not have any meaning. For an example, we have one word called intelligence, intelligent, and intelligently. Okay, what you will get from stemming intelligent? Now there is no word in English language called intelligent, right? So this problem we have. Let's see what are the stemmings we have. We have different stemming methods. So we'll try to explore few. From NLTK, we are importing NLTK over here, and from NLTK.stem, the module.stem, we have Porter stemmer. We will be creating an object of Porter stemmer, and we'll be using it. Now to use Porter stemmer, we need some words. Now here I have created a list of words. The list contains eating, ate, writing, programming, programs, history, finally, finalized, hyperparameter, sleeping. Let's run a loop. In this loop, what we are going to do, we are going to take the word, we'll print the word, and we will print the stemmed form of the word. We'll print the stemmed form of the word. Let's run this, and here you go. Now, eating become eat. It is completely fine. We are getting the root form. Eats also become it. Eight is eight as it is. But the root form, what is the root form of eight? Anyone? What is the root form of eight? Eat only, right? So it is not converted. Writing become write, fine. Programming and programs become program. That is fine. Till here it's working fine. But history, it is the word itself. It not need to be changed. Now here it is making history as history, not English word. Now finally and finalized become final. Now guys, tell me, is finally and final having the same context? Finalized and final is the same context? Having the same context? No, right? It is completely different. Now finally should be finally only. Finalized become finalize. It should become finalized. So final is not the correct root form of this words. Hyperparameter is becoming hyperparameter. Again, wrong. Sleeping is sleep. Fine. So you can see the mistake, and one more mistake I'll show you. Stemming not stem. Congratulations. It will become congratule. Again, no English meaning. We have few more stemmer over here called Lancaster stemmer. Lancaster stemmer is similar to that only, but not similar. It is worst, we can say. Aid become at, right become rit, history become hist, finally finalize become fin. So people are not using this stuff. Then what we have, regex stemmer. Regex stands for regular expression stemmer. Regular expression stemmer. Now, what is regular expression? Regular expression means what? We can give a sequence of text that we want to remove from the beginning, from the end. So when you are going to create an object of regex stemmer, regular expression stemmer, you're going to put the regular expression you want to remove. Let's say ing. You want to remove ing from all the words like cooking, eating, swimming. So ing dollar sign. So ing dollar means what? If I'm going to put dollar over here, so ing will get removed only from the end of the string. Yes, exactly. So s from end of the string, able from, like s is going to be used, let's say cars, chairs, tables, s will get removed. Able, let's say rechargeable, changeable, wherever we are having able will get removed. Then we have un. Here we are not giving any dollar sign. If I'm going to put dollar sign before, so from before it will get removed. If I'm going to put after, from after it will get removed. If I'm not going to give any dollar sign, so it may get removed from both end, from before and after, from like starting of the string or from the end of the string. There is one more parameter called mean equal to 4. What does it mean? Now regular expression will get applied only on this regex stemmer. Sorry, regex stemmer will get applied only on those particular, only on those particular words that is having minimum 4 characters. Having minimum 4 characters. Just a second. Yes. So let's create this stemmer and we will try to check few things over here. Eating become eat, cars become car, unhappy become happy. Okay. If you will ask me what is the sorted stemmer, this is the most sorted stemmer that you can use, where you can mention all the things. Okay. And it will work only on this particular regular expression that you have mentioned. Apart from this, it is not going to make any changes on its own. It is very cut to cut. Then we have snowball stemmer also. Snowball stemmer will work in the same way that you have seen the portrait stemmer, right? Now, what we have one more technique that is better than stemming. We call it as lemmatization. It is quite similar to stemming, but here it is used to group different inflected form of the words. Here we call it as stemma. So sorry, lemma. Here we will be calling it as stem. In stemming technique, we call it as stem. Okay, stem. Here we call those words as lemma. Now both are doing the same thing, stemming, and the main difference is here. What is that? Stemming and lemmatization is doing the same thing, bringing the words back to its root form. But the main difference is there. Lemmatization, when it is going to produce the root word, it is going to have meaning, meaningful word. Every word that it will produce, it will be having meaning. Now here in lemmatization, if you are having this word intelligence, intelligent, and intelligently, all these things are coming from this root word intelligent, which has meaning. So you can blindly trust lemmatization. You can go with lemmatization. So to use lemmatization, a lemmatizer, you need to download one thing from toolkit NLTK, wordnet over here. Now, if you are going to download, you will be able to use from stem wordnet lemmatizer. And you will be creating one object over here of this wordnet lemmatizer. And this object will help you to lemmatize. Here we are calling it lemmatize, not stem. Now, we'll see the difference. Now, here we are using the same list. the same word list that we had. Now here word and lemma dot lemmatize those words. But lemmatize is going to have one more parameter, that is POS. POS stands for part of speech. Parts of speech. I hope all of you have studied parts of speech in your school time. Noun, pronoun, verb, adverb, all this stuff. So this V refers to verb. And I think you know most of the time, the lemmatization that we need to perform is going to be on verb only, right? If a name is there, what if there are many POS? Now, if you have many POS, you can put the list over here, list of POS. It will work on that, or you can perform the lemmatization in two different ways. But mostly, what we need to perform on verb only. Okay, let's run this. So POS I have mentioned V. So V is for verb. And I think you are not going to perform lemmatization on noun anytime, because noun means what? If you have dogs, then only you want to make it dog, right? Let me just run this and we'll get the things done. And here we go. Eating become it, it's become it, and here it also become it, right? The clean part we can see. Writing is right, perfect, programming, programs become program. History is as it is. Finally is finally only as it is, because there would be no root from over here. Now finalized become finalize, right? It removed ed from, sorry, d only from here. Hyperparameter is as it is. Sleeping becomes sleep. So you can see there is a word called accordance. It will become accord, but lemma will make it accordance. Okay, now what we'll try to understand how basically we can create a pipeline. So whatever we have discussed so far, how we can put all these things in a order, so that our work is going to be done. The pipelines. So here we will be using the same corpus that we have created, and what we'll try to do, we'll try to tokenize the corpus, then we'll try to apply the stemming only on those words, those were not the part of stop word. That means we will stem the words, we'll remove the stop words, and then we are going to create a new corpus or the new data, clean data. Okay. So here, what we are doing, this corpus that we have, we are going to take Porter stemmer. First of all, I'm going to take Porter stemmer over here. You can use other stemmer technique. You can use lemmatization also. First of all, what we are doing, we are breaking down into sentences. We are breaking down into sentences, and we'll print the original sentences. First of all the sentences, list of sentences. Here we are creating one object, that is of Porter stemmer, and we have created a loop that is going to iterate on the range of length of sentences. How many sentences we have? 4. That means 4 times this loop will execute. Now in each iteration, what we are going to do, we are going to create a list of words. NLTK.word tokenize. What to tokenize? Yes, I'm just what I want it from you guys. Nirmal, you are saying right. If lemmatization gives best result, what is the use of stemming? The thing is that stemming developed first, and after that people develop lemmatization, right? So it's on you what you want to use. I'm showing you, I told you, like I'm showing you with the help of stemming, I want you to use lemmatization. Okay. And whenever you're going to work on this file, guys, do work on your own file. Okay. Create a copy of this file. Don't work on the original file. Fine. So here each time for each particular sentence, so sentence is nothing but over here, this is the list of sentences, right? When you're going to convert it into sent tokenize, it becomes the list of sentences, right? So it is going to store the corpus over here. So sentences will get printed. Now each time, like first time here, with the help of range, index will be 0, I will be 0. So 0 means what? The first sentence will be taken. Sentence is going to be taken as the word tokenized. That means it will return the list of words. These words will become list of words. Now on this list of word, we will run the loop again. Now here you can see the example of list comprehension, guys. What we are doing, just try to focus over here. Stemming dot stem word, that means stem the word and store it over here in this list, where, so first of all we are going to check with the loop for word in words. We are iterating over each word. If word dot lower, why dot lower? Because few, all the words that you might have seen in stop word list, it was in lowercase. If word dot lower, if that particular word is not in the list of stop word, we are taking each and every word from this particular list and we are checking if that particular word, if that lower form of the word is not in the list of the stop words of English language, then stem down the word and store it over here in this list. So here what we are trying to do, we are trying to filter out, all the stop words. We will remove the stop words and we will keep only those stop words, those who are not in the list of stop words. And we are going to store it. Before storing it, it will also get stemmed down. Once it is done, so what you will be getting a list, right? Now what we are going to do, we are going to join it back in the form of a string. So join is a string method that is going to be used to join the list elements to form a string, a sentence. And here I have mentioned a space. So based on space, everything will get joined and it will get stored in that same index of sentences. Okay, let's run this. Here you go. Now what happened? For the first particular line, we run this thing. I don't drink coffee. I was the stop word got removed. Do was the stop word got removed. It should also get removed, but it is there, NT, because of Porter stemmer. And few more mistakes you can see. Coffee become coffee. E is missing. Fine. What a wonderful day. Now what these two are nothing but stop words. It got removed. Now wonderful, the Porter stemmer wonderful make it wonder. What a wonder day. Wonder day. Timon and Simba went for a party. Timon, Simba went party. Party spelling got changed. India will play with Pakistan in World Cup. So India play Pakistan World Cup. Will is the stop words got removed. With is the stop words got removed. In is the stop words got removed. So this is how we have created a pipeline for level 1. This is for level 1. We have completed level 1 right now. Okay. Now here, let me give you one example over here. Here we are using a split. We are using join, how basically it works. So let's say I am having this word, this particular string. What a wonderful day. Split is going to convert it into the list of words. Here you go. Now, if you're having a list of word, so this list of word can be joined back with the help of join. Join the list elements. So how I'm going to join? With a space. Let me just show you. Here it got joined with a space. If I want to join with a comma, I can join with a comma. Here this is a separator. Okay. is when I give space, the space is the separator over here. If I'm going to give hyphen, hyphen will become the separator. If I'm going to give plus, plus will become the separator. So here I am using this thing, join. Clear guys, making sense? Clear till here everyone? Is it clear to all? Okay, one question from Poojan. Sir, then what is best method, lemmatization or stemming? Lemmatization. In lemmatization, if you talk about stemming, you can go with regular expression. But here I will consider lemmatization only. Okay, all right, guys. So we can take a break over here. We can take a break, and we will come back after break. Okay. We'll come back after break at 1 o'clock. Okay. After coming back at 1 o'clock, we'll discuss the level 2 and level 3. Attendance will be given in the next half, right? Attendance, I am going to give you attendance link in the next half. So as of now, we have covered till here tokenization, stopwatch removal, stemming. We will be talking about vectorization and model training in the next half. Okay. All right. Thank you, everyone. See you after the break. I'll keep the meeting on. You can join back after the break.